we're ready to begin. So the reason why we are here is because we have something to show you, and we would like your feedback on it, maybe. It's a new Kubernetes cluster, but with a twist. So during the presentation, feel free to ask anything, especially on Menti, and feel free to scan this so that you can ask your questions, and we will answer them at the end of the presentation. So yeah, short introduction. My name is Christos, and I am a principal architect, platforms design in Vodafone. I've been in Vodafone for a little more than 5 years. Previously, I was the API development cluster leader, and my team and I built the digital experience layer or the Excel.
Hello, welcome all. I'm Nikolakakis. I'm the side that I've been the cluster lead.
Thank you. So in order to understand the problems that we're trying to solve and what we did and why, most importantly, we're going to make a small run-through of Vodafone and the complexity of Vodafone. And then we're going to talk about what we did and how, and the people that run it. So as you may all be aware, Vodafone is a major telecommunications provider and have approximately 100,000 employees spanning across many countries. What you may not be aware of is the sheer amount of complexity that this organization has. We have many systems deployed, and out of the major sections that we have in the organization, two are of interest for this presentation: the digital section, where we have HTML, e-commerce, the website, and the digital experience layer serving all of the channels. And of course, the core IT, it's where the master systems lie, it's where the master information gets. A few years ago, FYI, Vodafone took the decision to modernize their stack. And we started with the digital section of the organization and with the DXL. And right now we are proceeding since 2023 with the core IT department. So Vodafone has a lot of history, and in order to understand our technical undertaking, let's just imagine that we understand what is the picture on the right. You don't have to distinguish what the letters write. You just have to know that those boxes right there represent capabilities that we have. And below those capabilities, there are multiple systems deployed. So in total, we have approximately 150 distinct systems deployed in the core IT world. So we have a lot of history and we have a lot of legacy. So how do you even begin changing things like that? How do you even begin modernizing your stack? And most importantly, how do you keep track and how do you adapt to the requirements of the modern age? Everything today is near real time. This was not the case a few years back. So a little bit about the origins of our new cluster. We, as mentioned, we started the modernization of our stack with the digital, and that's where we built the digital experience layer or the DXL. We have made a number of presentations about the DXL, and it's a subject on its own, so I'm not going to invest too much time here. Suffice it to say that it's based on the CQRS pattern, meaning that we stream data from the corporate IT world onto DXL. We then save it, having it transformed into a MongoDB database. And then when we have to fetch data for the digital channels, we fetch it from MongoDB. When we have to alter data, any kind of data, we pass through the corporate world. So using this methodology, we were able to alleviate much of the burden of the corporate IT world, and the systems were already reaching their limits in the digital channels. So the DXL was a breath of fresh air. And we were able to improve our response time by more than an order of magnitude. So in general, it was a success, but it brought us, we faced a lot of non-anticipated problems that stems from our enterprise nature. It didn't always have to do with the traffic that we serve each day. That let's give a quick run through of the problems that we face. First of all, an enterprise like Vodafone, most of the time, the technical components of a major system are not being served and are not being developed by the same team. And that means that usually when we have to expose an API, we may have to order, we have to make demands to an external team for this API, for the API gateway to expose this API and connect to our microservice. Or when we have to create a new topic on Kafka, we have to make a demand to another external team to change the infrastructure. So infrastructural changes are being done by different teams. And that creates also a bottleneck on the solution act. We are usually the people who are usually the people that are responsible for syncing everything, syncing the development that takes place for new APIs to be exposed, syncing the demand in the different parties to bring everything in place so that the new APIs can be delivered and function correctly. And that creates a lot of bottlenecks. So finally, let's just say that you want to change something major in the platform. Let's say that this is a new authentication system. You want to change the authentication from A to B and how can I connect? Or to change the JWT, or to make anything that touches 170 microservices. How do you do that? I can assure you that all the times that we did that, the response was, oh my God, it really is a pain. And no matter the level of readability of the pipelines that you have, this is a problem in big clusters. So we took all of these factors into account when designing our new solution. And as it stands now, we believe that we are on a good path to solving that. So the new cluster is called CEL. It stands for Componentized Enterprise Logical Layer. That's the last time that you're going to hear about it, CEL from now on. And every new project in Vodafone and every new platform in Vodafone starts with a certain amount of research and development. But the architecture that we are going to need in order to bring this to fruition. So we searched everywhere, and is there any one of you who may not or who is aware of what TM4 is before we proceed? Yes? No? Most probably not. Okay, so TM4 is a global telecommunications organization. Its goal is to promote reusability across telecommunications companies. And right now, we only hear about it because we use TMF APIs. So Vodafone is a key player in the telemanagement forum, not only because we have contributed APIs and we use APIs everywhere, but also because when it comes to the ODA architecture, this is what we're going to talk about today, we are also key integrators and have a lot of architects working from Vodafone into evolving the ODA architecture. Don't worry, we will explain what it is right now. And that's why we're here, actually. So we decided to use the ODA architecture to modernize our core IT stack. And let's just take a moment to remind ourselves how complex the core IT infrastructure is and the problems that we have encountered when building the DXL, which would only multiply if we try to do the exact same thing on the core IT. So what is CEL? CEL is the microservices cluster that we hope that we modernize our core IT. And it will allow the team to work together on the same cluster and also on the same microservices without relying on one another for their release process. So it will decouple teams together even if they use the same microservices. It will also decouple the environmental concerns from the software development, meaning that from now on, software developers will not need to worry about what the monitoring will be, how they're going to configure the microservices to send events to OpenTelemetry or anything like that, and how their API will get exposed. And as a consequence, it will remove the burden from the solution architects and the DevOps. That's who right now are doing many things manually. So this is a very, very, very high level, 10,000 feet level depiction of the cell architecture. We use the API 6 ingress gateway. We don't use it only as an ingress controller. We use it as a gateway, meaning that we also use it to connect to a keycloak instance that does the OpenID connect for us. We use Quarkus for developing microservices, but also for developing Kubernetes operators. Has anyone developed their own Kubernetes operator here? Yeah, 1, 2, 3, 4, 5, 6. Yeah, 10. That's quite nice. So we're going to talk about how we use why we need Kubernetes operators. For code sharing, we have GitHub Enterprise. We use this in our cluster. And we have everything in code. So we have a bunch of Terraform scripts for the DevOps area that automate and they declare everything that we have. So before we dive into cell, that's because I invested some time in the release management. This is how we solve it. In microservices cluster, you usually have microservices that are using other ones. And as a consequence, there are some microservices that are considered core. So on the left side, it is very simplified depiction of what happens a lot of time during our DXL development, and I suppose in other clusters as well. The person who wants to release something the next week, there is a change that demands going back to the drawing room, but there is another team that has already planned your release to happen so that they can continue working on it, so on and so forth. So 100 microservices, 16 teams, this is going to create a mess. So instead, we bundle, according to the ODA architecture, we bundle many microservices in something called ODA components. So we group them, and they all serve to expose a single API. And in the rare case where there is a team that wants to use a microservice, they can redeploy it as they want, like a scheduler or a mapping microservice. So this can happen without the other team having any problem whatsoever, because they will have a separate instance inside their own component to serve their needs. Now getting a little bit deeper, I suppose that I saw some hands earlier, so I suppose that the people who create their own operators also are familiar with the custom resources, how they're used. For anyone that may not be aware, custom resource definitions are a way to extend the Kubernetes API. So instead of only understanding deployment services, it can also understand whatever we please. It may be a network, maybe a component, in this case. So the ODA component is a key differentiation factor between Cell and any other cloud. And the ODA component is an integral part of the ODA architecture. It's actually a bundle of microservices grouped to expose a single API. This bundle can be only one microservice, or they can be more. Regardless of the size of the ODA component, it will always be accompanied upon deployment time with the component YAML, describing the functionality that it needs to operate. For example, the authentication system that it needs to operate, how it's going to expose itself on the API gateway, under what URL, monitoring, or if it listens or propagates an event. And of course, it's packaged as help. So who uses this ODA component? The ODA canvas. The ODA canvas is what makes Cell what it is. It's a collection of Kubernetes operators that read the component specification and try their best, and they succeed in configuring and setting up the infrastructure to a state where it's ready to accept the component. For example, configuring the API gateway, configuring any Kafka, configuring any infrastructure that we see fit. So the component specification is part of the ODA standard. Right now, I believe it will be one beta. And this is a high-level operation of how Cell Canvas operates. On the left, we have a Cell component at the time that it gets deployed inside Kubernetes. For deployment, we have the first operator that takes place, the component operator. The component operator reads the component specification that actually has been deployed, and according to the domain of interest, API, event, authentication and authorization, it generates sub-resources or secondary sources, also according to the API specification, that are specific to the domain that we want. For example, API specification that can be source, or the event specification, or the monitoring specification. And subsequently, there is another array of microservices that of operators, on the campus that take, for example, the OTA API specification and configure the API 6 gateway. The event operator configures the event notification mechanism that we have. Actually, this is a cool thing. We will show it later. And of course, the monitoring operator configures the entire component so that it can be easily taken advantage of by Datadog. So I have put more of this because this is not all. We are adding new operators according to how the OTA specification evolves. And of course, we have some custom operators on our own and webhook. So the result is that the developer or the solution architect is not concerned anymore about how the API gets exposed. They are not thinking in teams. They don't have to invest any time into how their component will work in the end. And that actually reduces a lot of time, in some situations, maybe even months. So an example of how powerful a Canvas-like architecture could be is how we have set up the event notification mechanism. So let's just say that we have a business case. We have a component that, according to the TMF spec, receives a notification as a REST API in a certain topic and wants to propagate this notification to all listeners using Kafka. So there is a conversion from a REST API towards Kafka so that we have many listeners. So how we solve this issue? We could have done it manually, of course, but we don't know who will need an event next time. We don't know in advance how many topics we will have. So in order to avoid all this manual operation and manual development, we have an event operator that does the following. Is upon deployment of a component that is a listener on a specific topic, or is a creator of an event on a specific topic, the event operator creates a new deployment of a microservice that we have that listens only to a specific path, so /topic/A/B. Of course, since it is a single deployment, it can be scaled using horizontal autoscaler without affecting any other topics. And then, frequently, because we have dynamic paths, the event operator also configures the conf micro gateway that we have. This is not the main gateway, by the way. It is a micro gateway. We use conf for its declarative nature. So declaratively, the event operator changes how conf operates and adds new routes or deletes them upon the deletion of the component. And then it configures Kafka for the new topic to be created. And also, subsequently, actually, this is not depicted here, it also performs validations of the messages, again, following the ODA specification. So new messages can be added, new events can be added, and we can have custom validators without changing or altering any code whatsoever. Anyone who wants to have new events propagated inside the cluster doesn't need to ask anyone before they implement it, or actually they use it. So there we have it. This is a small depiction of what's selling, and those are some numbers. Those are some numbers that depict how efficient we now are compared to how we were before. Those 15 days that you see on the API gateway exposure, the new notification channel, were actually the days that we spent back and forth with external teams when we were deploying this new API. And it was actually a very good time, those 15 days back then, because those teams actually have their own governance model that they want to take care of. So they run their own regression tests. They have a housekeeping to do. So, the 15 days for an enterprise organization is actually one sprint. It's not that long. But still, right now, since we have automated all these procedures, we have approximately all those operations are being done in 3 seconds. And now I would like to take a moment and go into the funded data, not actually funded, in the imagination area. One, we have Terraform everywhere. So that means that if one presses the button, they can create our entire infrastructure. EKS, EC2, everything on Amazon. We also have ArgoCD that will subsequently deploy all business applications and the cell canvas inside the cluster. And then we will have the cell canvas itself, which at the last part will take care of how this component gets exposed. So all this new infrastructure will never need any configuration. Everything will be done automatically. So if we wanted to do this, how long it would take? 15 minutes, 16 minutes. Okay? And that allowed us to have ephemeral environment. It is a pain point in major corporations. And 16 minutes is actually the real time. We have a new environment along with the business components, along with the API gateway exposure, and everything works correctly in 15 minutes, in 16 minutes from scratch. So that would be number one. Number two, the reason behind creating an ODA canvas. Remember, big organization. What would happen if we wanted to make a drastic change? If we wanted to take a microservice on an entire ODA component and put it into another cluster with a totally different environment. Maybe Conf gateway, maybe something else. Maybe not using Terraform, maybe using Instant. In traditional and the way we actually did it, until recently, we would have to make some changes in the logging mechanism, maybe taking into account PWPs, stuff like that. But imagine if the destination cluster also had a canvas implementation itself. So what we would have to do is just ensure that there is an ODA canvas in the destination cluster, listening to the same specification, and it is a global specification because it is ODA, and everything would work automatically. And imagine how that would play out in a corporation like Vodafone with many local operating companies. So that would maximize reusability of microservices, and the only limitation that those microservices would have would only be the business model, how they would set the business model. So we reduce the amount of effort spent on environmental concerns with this architecture. So, when designing and developing Tel, we stumbled across not a problem, but a challenge. We knew that for developing the ODA canvas, Telecom, we either needed software engineers that would be great DevOps engineers and have a thorough understanding of how Kubernetes and Amazon work, or we would have seasoned DevOps engineers that are also working as the software engineers to develop custom operators and also understand how everything plays out. So this is where I pass the microphone to my colleague here.
Thank you, Christos. Hello, everyone. Okay, now we will speak about the SRE framework methodology, how help us to build the cell actually. So, okay. Okay. So let's distinguish between SRE and DevOps, because many people have confused about this. Let's say methodologies. It's the same in some point, but the DevOps, the primary focus to deliver many things, automate and have the delivery speed up. But SRE are focused to emphasize to reliability in our infrastructure, in our service. So this is the difference, but the goal is the same for both things. Here in this diagram, we saw in the other teams, maybe we have in our organization like operations, software engineers, developers. All of these teams have the same goal: the service be up and running, the servers, all the infrastructure. But SRE is with the methodologies they use can be achieved this. So to achieve this as SRE, we have 5 principles that is coming from Google because SRE is a standard from Google. So this one is the 7, the embracing risk, the self-level objective, the illuminating toil, the monitoring distributed system, automation, release engineering, and sleep. All of those have a key part for what they do in the service. But let's go further. Now here we present how we monitor in cell, how is the key methods we use, and how the operator acts we have built. The key methods is those you can see: the latency, the traffic, error rate, saturation, the availability, the request and success rates, the dependent failures, end-to-end transaction tracing, and SLIs and SLOs. Now, at the moment, we use Datadog, Splunk, and OpenTelemetry to collect all of this. And here we can see how SRE be part in the life cycle of cell, and not only of cell, but generally cell at the moment. So we be part in the design, in security, of course, because security is very important in our days, in the deployment, in the monitoring and alerting, and of course, here we use testing. We don't mean the testing about the service testing or infrastructure or something like this. We want to bring new stuff, new technologies, new methodologies in our cluster. So at the moment, we test and develop how can embrace house engineering using house mesh at the moment. In the other stages, you can see, for example, in design, if we want a new operator, we use Java to build. For version control, we use GitHub, Access was mentioned before. For security, we have in place Hiberno, Trivi, Istio. Now we take Kubernetes also for runtime. In our deployment, we have help from SonarCube, Argo, and the monitoring and alerting, as we mentioned before, the Datadog, telemetry, and Splunk. Now, here we can see the 8 steps to achieve chaos engineering. We have wrote it here in the Go format. At the moment, we are trying to put all this together to have stressed intentionally our cluster in order to see how is the behavior of the service of the cluster, how, for example, how availability or cluster autoscaler works. And that's all for me. Thank you. Thank you, everyone.
That's what that is. The service reliability engineers are also responsible for the evolution of Canvas, the evolution of Canvas specification, and also the evolution of the protocol that we use. Okay, so we use OpenTelemetry, but What do we collect? How do we collect it? And of course, they are always in touch with our colleagues on the group, because everything that we do has to apply for other countries as well. Thank you. Thank you. We have probably a few minutes for questions. Yeah, I believe that we have a few minutes for questions, right? No? Yes, yes. Do we have any questions? Is there anyone who wants to ask anything? You ask a question. Wait. Let me see. Where is it? Okay. Okay. So, security. That was yours. Validations. What was your question?
Validation. What type of validation do you make when you pass?
That's actually a great question. Christos here is asking about the validations. If there are validations that operators do on the received input, how do we handle errors if someone puts garbage there? So, custom resource definition have a strict schema themselves. There are parts of the custom resource definition, like the security, is free for us to use. So your Kubernetes operator needs to validate the input, or it will throw everything away. We use mutating webhook configurations for that, to validate the input. And then we throw away everything that is not valid. It's not perfect. I mean, in this scenario, this is one of the things that you have to pay much attention to. And this is an area that is very, very, very dangerous. I mean, the more components you add to something, the more failures you may have in the future. So that adds an extra engineering complexity, if that was your next question. But yeah, operators do that, and Java allows us to handle more things in terms of having validators, because they have a strict model. That doesn't mean that Go wouldn't be suitable as well, of course. So we have some other questions here. Did I answer your question?
Yes. Last I follow-up question.
Great power comes with great responsibility. Security concerns. Security concerns. Yeah. Security concerns. There are a lot of security concerns, but they are not stemming from the architecture itself. It stems from everything that can happen until someone has the time to deploy to this architecture. We have a dedicated team working on patching holes and performing penetration tests in security. And I believe we have a questionnaire of approximately 250 items we need to fill. So yeah, those 250 items would be 250 security concerns. Not that we have to cover, but yeah. I don't know, ask this, I suppose. I hope I answered your question. How often do you upgrade the Kubernetes cluster, and how do we test it? I believe that there is a person more adequate than me to answer this question. He's called Nikos. He's sitting at the back. He's the DevOps chapter lead, and he, along with his team, set up the infrastructure on top of which we build the stuff that you see today. You want to answer that?
First of all, we follow the life cycle of AKS.
Yeah.
We rely on AWS. So we follow.
Can you talk a little bit louder?
The support schedule AKS. Yeah. Yeah. First of all, specifically is fairly new, so it was built with 125 from the beginning. I think we've gone to 127 now. First of all, the key here is the ephemeral clusters. So basically, a very difficult thing that we had to do in the past was to upgrade something that was running live, and we had to do it during the night, etc. Now we are going with a blue-green approach, even for the cluster. We create just a new cluster and we deploy everything there from scratch, and we just switch to the new cluster, basically. So this makes this makes it much easier. The problem that we have to upgrade the actual existing cluster derive mainly from security concerns regarding the auto-scaling groups that we have, the images we use that are internal, custom, hardened images, etc., that are not very flexible to update. I can go to many data.
One final point. When we are testing the new Kubernetes cluster, we would also test the components themselves, the component operators themselves. They are part of the cluster. So the OTA canvas, at least the reference implementation, has a testing toolkit which is currently under development. And of course, OTA canvas as a specification is currently under development and evolution. So we do have some automated tests running to test the functionality of operators. In terms of development, this is very easy because with Quarkus, and if we had Spring Boot, it would be the same. We have a lot of options in terms of unit testing and integration testing before something gets deployed in Kubernetes. So we have a lot of options there. But when it comes to testing the canvas, is actually a key point of interest when creating clusters and testing the behaviors of operators and other components.
Questions?
Yeah, please.
How do you maintain state inside the meeting camera? I saw that you have also Kafka and type that. So what are
Kafka is not
next version?
So we relied mostly on AWS services for everything. So that goes with Kafka. So it's MSK. It's outside.
It's
outside the place. So we try not to rely on stateful stuff within the cluster. And also the same goes with the databases. There are the database outside the cluster.
So no stateful workload inside cluster.
Yes. As much using the actual AWS service.
Sorry for not making this clear.
And testing. I mean, test the cluster before it goes live, the new one, and every component within the cluster, and then you just switch the load balancer.
Yeah. Even the gateway, even the API 6 gateway will have an internal state. It also saves its configuration on external Postgres, and Kong does the same. So this Postgres is always external for pre-prod and have a separate instance for production. And we are taking advantage of this to throw an ephemeral cluster by having also the exact same application logic between development, staging, and stuff like that. Okay. Is EKA specific or is self EKA specific or cloud agnostic? Cloud agnostic. It's stemmed from OTA, which is cloud agnostic in itself. The only thing that it needs and it requires is Kubernetes to exist, and everything else standard Kubernetes, whether you are in cloud A or cloud B. The thing that makes self or OTA, an OTA architecture cluster cloud agnostic is the operators. Those operators are infrastructure specific, meaning that if anyone wants to develop an OTA cluster, they will need to develop their own operators, or at least use the operators from another person who has the same exact infrastructure as them. For example, the API, the API gateway. you do need to develop your own API gateway operators. So is Greece production running entirely yourself? No, I didn't read the rest of the question. No. We have so many systems, 150 systems. I don't have a time frame for how much it will be, and it doesn't make sense to run the Greek production all in a microservice cluster. I know that we are on a Kubernetes meetup, but not everything makes sense to be migrated in a microservice architecture. So every time that we have something new to do, we examine microservice architecture, but I don't believe that everything will go there. So no. Which country is next in line? I can't comment on that. Greece is currently here, and it's us. What about people in internal organization? Did you train your current team for new technologies? Yeah, this is a nice question. The SRE part is a nice question.
Is the principle of SRE. So yes, we have a wiki. We have meetups all together, and we educate ourselves in general. Where a few months before we make a hackathon also here in our premises for our employees. So yes.
So one more thing. Initially, when we started developing the whole thing, we were in the experimental phase, and we brought a few people that were software engineers. These people are with us today, and those software engineers were very, very, very keen on learning more about Kubernetes, how it operates, and develop their own operators. In fact, we have people that moved from being software engineers into being SREs. So initially, we trained software engineers to develop our operators. We made them part of our, let's just say, culture, software engineering culture, to know about Kubernetes. And now we have created a dedicated SRE team to handle those things. So this is why I don't know how it is in other companies. I really don't. And I don't know how it will be the standard. But for Shell SRE, software engineering is a big part. You have to know how to code.
Guys, how organizationally, how your feedback flow back to the development? So you said you, I think people can hear me. You figure out by throttling some API that has some performance issues, it can't go with its traffic. So how does the team learn? How do you organizationally make sure that the feedback flows back to them?
Until now, based on what we have written in the alert and the monitor, we give feedback straight to the developers. So we have a meeting with each other and all together trying to solve the issue.
When you have regular meetings.
Yeah.
Actually, what we need to say is that they are part of the same team. The engineers, in the new structure, at least now that we are doing agile transformation, the engineers and the SREs are very, very close in their everyday life. So they don't need a meeting to start exchanging information. Since the SRE will be involved in the design phase and then in the development of the Canvas phase and all phases of software development, they will get the feedback. There's no way out of this. Okay. As far as I know, CRT is a cluster-wide resource. How do you handle the operator upgrade itself? That's a very good question. Would it be strange if I told you that we just updated? We just deployed the new version, but we have a tons of regression tests that we are doing on the development phase to ensure that nothing breaks, and the ODA specification itself is also assumes, and for a good reason, that you have a converter and webhooks to ensure the conversion from one beta to the other. so that nothing breaks. So if something is left with the previous definition of V1 beta 1, and we want to migrate to V1 beta 2, the webhook will take care of the conversion, at least in the CRD's upgrade. We have a webhook that converts to and from the latest and the old definition. But if something goes wrong, yeah, it depends on the scenario. One thing that we were discussing with Mr. Tsakalos is how many people are using local infrastructure inside their laptops to test the operators. I don't know how they're using it, but all of the people that are working with Kubernetes in Cell, they do have a local cluster and an ephemeral cluster. I use Obstack, others use micro-K8s, but we are creating clusters on the fly, putting out the operators and the entire canvas inside, that's 5 or 6 operators, and making test deployments to see how that behaves. So that is an extra layer of safety, I would say, not security, but safety, before we change something on the canvas, which is so core. So we have CDKs, compliance test kits. We have unit tests on the microservices. We have extensive tests locally. We have testing environment completely out of business components only with Canvas. And for now, it's enough. Maybe in a year or so, we will have another meetup and we will have come with something more appropriate. But for now, this has paid off.
So we'll do one more question and then to the next presentation.
Yeah, of course. For everyone,
You want to have one more question?
one more. Not everything should be a microservice, as you said, but is your plan to use tools for everything to eventually join? No. The answer is no. Vodafone has 150 systems, and with that, we have a lot of things, and we have needs for physical stores and stuff like that. Not everything has to be around inside microservices, but many things will eventually go and will be replaced by microservices. But there is still room for a lot of in Vodafone, and for good reasons. So, yeah, thank you very much.
Thank you guys, great presentation. Now we will hear what Nestoras from Narrator will tell us about Kubernetes.
Hello everyone. I will continue the presentation because all my colleagues are in New York and California, so it would be great to understand also what we are saying here. Yes. For the people that you don't know me, my name is Stefanou. I have been working in Narrator less than a year. My previous job was as a senior engineering manager. I decided to do this transition to go back as an IC because it was a tough year. As you know, it shut it down. So I was looking for something more challenging. Today, we will talk about empowering dynamic environments. I think it's quite a bit similar with ephemeral environment, but with a different name, and how we are doing that with Kubernetes, ArgoCD, and Terraform. Here you can see the table of contents of the presentation. What Narrator, serverless monolith transition. You will hear a lot of presentations, probably how we'll move from a monolith to microservice, but here you will hear the opposite because we're a very small team, and I will explain it further. After that, collaborate seamlessly with Terraform, Kubernetes, and ArgoCD. One topic about security, scaling and optimization, monitoring, observability, and incident management, future plans, and Q&A session. Okay, first of all, let's start with Narrator. Narrator is an end-to-end platform, and we are helping our customers to do data modeling, data preparation, dashboards, and some other things. So we're connecting our application to warehouses, and we are helping our customers to make the proper decision. Here you can see some customers that we have in our platform. We have some enterprise customers, some small startups, some other companies. So we can move to the next slide about the Narrator team. Narrator, founded by the creator of the Activity Schema. Activity Schema is an open source project, so if you want to learn more, feel free to search it. Of course, if you have any question, I will try to do my best to answer your questions. Narrator's mission is to help companies to make better decisions with accurate, efficient data, and our mission informs every step of product development. And we are backed by top Silicon Valley investors with the team hailing from Microsoft, IBM, and some other big companies. Okay, let's go to be more technical because I know you are all here for this thing. We will start with serverless monolithic transition. First of all, when I joined the Narrator, I found 50 microservices distributed across Lambdas and ECS containers. After that, I found that we are using a lot of CI/CD tools like GitHub Actions, AWS Code Pipeline, step functions. So it was really hard for me to debug all of these things because I will mention it in the next slide. We are a very small team of 5 people, and I am alone. So we had a problem, and I was started to find what is the problem, and this made my life really, really hard. After that, we didn't have anything for monitoring. We used CloudWatch, and CloudWatch was the most expensive thing in AWS service. So we had 50 microservices, and I was trying to find all the information that I need there when we have a problem. After that, I was looking when we had an incident, what we are trying to do, if we have runbooks, if we have anything else, to learn how we can fix all the problems, and we didn't have anything. So after that, I was trying to understand what we are doing. Like, okay, we have an infra. Can I find all the resources, or I need to start looking in AWS? And we use CloudFormation. For some other things, we use AWS CLI. For some other things, we use Terraform. So it was a totally mess, and my life, it was really, really hard. And of course, after that, I had a meeting with the CEO, and we had a requirement that we need a multi-cloud support. And as you can see in the next slide, we had a lot of AWS vendor locked services. As I mentioned before, the team is really, really small with 5 engineers. Our infrastructure cost was really, really expensive for the size of the company. And, I had a lot of feedback from all the backend engineers that we don't have parity in our environment because, we are using AWS vendor locked services, so it's really hard to follow something in the development and after that in staging. And if we have a multi-cloud solution, it's really hard to find in Google Cloud services like the services that you can find in AWS. Okay, so let's start with our objectives. First of all, we made a decision that we need to move from 50 microservices to 5 larger applications because our team is really, really small. After that, we need to find all the tools that we are using, and we need to start using cloud-native tools. So if we want to move in a multi-cloud solution, we want to have also the same tools to make our life easier to debug when we have a problem. After that, we need to automate everything because we don't have time, we don't have testers, so you need to do a lot of things. So every time that we want to do an upgrade, because we are storing data and we have a lot of compliances that we need to follow, it was really hard. So this is the reason that I will analyze in the next slides that we have except tests in application, we have tests also in the infrastructure side. And one more thing, we need to move fast and don't break things because we need to protect the reputation of the company. So we had some EU customers that, if I remember correctly, the number is 3. So we decided to create a prod EU cluster, first of all, to take feedback from our customers if everything works properly. And after that, we will proceed with the prod US customers. And there we have, let's say, more bigger customers that we need to treat really, really well. We got really good feedback from the prod EU customers. So this helped us a lot to avoid some mistakes that we had. And after that, we proceed. It was quite painful because for 3 weeks, We maintained two different branches for all the changes, so this was quite a bit hard for a small team. Okay, let's start with collaborating closely with Terraform, Kubernetes, and ArgoCD. Here we are organizing our tools into some categories. First of all, we are using Terraform for everything. This is a strict rule. We are using also, for the Terraform, we are using the Terraform modules mainly, but we have some specific things that we are not able to find out there, so we developed our modules. But mainly we are using community modules. They have very good modules. They have also testing for modules, so it was a great decision. After that, we are using Terragrant. Terragrant is a tool that's created by Groundwork and helps you a lot to help you with all the dependencies that you have. So if you have dependencies, if you have very big state, Terragrant will help you to make your life easier. And after that, we have Terratest because we need to do upgrades. So Terratest helped us to write code and implement that when we are doing an upgrade like in EKS, we can create the whole infrastructure from scratch in a different AWS account, follow all the steps like we are in Kubernetes 1.28. We want to go to 1.29. So this will follow except the same steps. So it was something that helped us a lot when we are doing these things that we will not have any downtime. After that, we have the platform. We are using Kubernetes. We are using EKS. We are using a managed service from AWS because, as I mentioned, we don't have engineers to maintain the control plane. Also, we are using ArgoCD. ArgoCD is updated to do all the updates and releases that we have in our applications. And we have some Kubernetes add-ons like Inverse Controller, Carpenter, Fluentbit, and stuff like that. For the monitoring, we decided that we need to delete everything from CloudWatch, which made me really, really happy. And we decided to start using Grafana Cloud. I know that probably a lot of people from you, I will hear the feedback, let's say that Grafana Cloud is really, really expensive. But right now, in the state that we are, Grafana Cloud is an amazing solution, and this helps us to build very, very quickly a monitoring stack in less than, if I remember correctly, 20 days, and to have logs, daily tracing with log tempo, and also we are using Grafana Incident to help us to pay our engineers. And the last section is about secrets and configuration. For secrets, we are using Doppler. To be honest, I didn't know Doppler. It was a managed service. I'm a huge fan of Vault, but I don't want to add one more component to maintain. So I decided to stay with Doppler. It's really simple. They support the Terraform provider, so you can have all your secrets in Git. And we encrypted all the secrets with SOAP, so no one can find all of these things. And of course, we are using Terraform vars, and I will explain in the next section how we are doing the combination between all of them. Here you can see the flow that we have for our infrastructure. First of all, we define our Terraform code and Terragrant code. And if we have very big changes for our infrastructure, we are creating a new version, because when we're creating a new version, we want from Terratest to create the whole infrastructure in a different AWS account and deploy it after that to ensure that we can proceed with all of these changes. After that, Atlantis TCP for Terraform, we are waiting, of course, for the approval. And when we are getting the approval, we can plan the changes. And if we are okay, we can proceed with apply. After that, if we have changes that we need to propagate in Kubernetes, we are using ArgoCD and ArgoCD Mat Updater to propagate all of these changes in management cluster, prod US cluster, and prod EU. Let's see also the flow that we have for our applications. Of course, I didn't mention in the previous, all the commits must be signed because everyone can impersonate. Of course, all the repos are private. So this is a strict rule that we have for all the GitHub repos that we are using. So we are opening a pull request in main, and if we are getting an approval, we are merging these things. GitHub Actions will run the test. and after that they will create a new release version. So when we have the new version, ECR will notify ArgoCD image updater that we have a new version, and this will deploy automatically in management, prod US and prod EU classes. It depends from the changes that we did. Okay, let's start find how we are combining Terraform and ArgoCD. First of all, as I mentioned before, we are using Terraform to provision all the infrastructure components. This is a strict rule. We don't do anything, and also we have an event handler. If someone did something by Terraform, this is the one joke that we used at big. We notified immediately, and we are getting alert to merge the state with Terraform. After that, we are defining all the Doppler secrets with Terraform and creating through SOAPs. And the only thing that we are deploying with Terraform in Kubernetes is ArgoCD, because we have the sticky neck problem. If I remember correctly, EKS will add a new feature to have ArgoCD as an add-on, but right now we don't have it, so we're using health provider to deploy ArgoCD, and after that, ArgoCD is responsible to deploy everything in our Kubernetes. As I mentioned before, we're using TerraTest, so if you open a pull request, you need to ensure that you will not break the Terragrant apply all command. This is a strict rule that we have, because if you are not able to run Terraform apply all command, you are not able to run all the tests that you have in your infrastructure. So let's say the layer that we have is Terragrant apply all. We are creating the whole infrastructure from scratch. After that, we have some tests like validations. Let's say Carpenter is in a ready state. Maybe our main application is in a ready state. So if everything is okay, we'll destroy the cluster, because also we are trying to reduce the AWS cost. So we are trying to treat our infrastructure as a castle and not as a ferry. And last but not least, all the Terraform outputs and Doppler secrets, we will propagate it in ArgoCD. I have an example of code how we are doing that. Of course, if you have any questions, feel free to let me know. In ArgoCD, we are using app of apps. If you are using ArgoCD, probably you know it. We have three main categories. If you are a bigger company, probably it's really good to break it down more, but at the size that we are, I believe that we have the Kubernetes add-ons, we have the monitoring stack, and we have the application. So every time that we want to do anything, we are trying to change the specific repos. We are not storing any secret and configuration inside ArgoCD, because it will break the dynamic environments. As I mentioned before, ArgoCD image updater, check for new versions, and ACR will notify to deploy across the Kubernetes cluster. And also right now we're evaluating Argo rollout, because we want to make canary releases and be able to make more sophisticated our let's say rollbacks, because right now, if we want to make a rollback, we have a script that we run it to delete the ECR image, and ArgoCD image updater will notify that we have a change and will do the rollback. Of course, we need to make our application backward compatible, because we will have problems if we don't do it. Okay, here we have two images. The first image is structure that we are using for Terragrant. As you can see, we have one folder _global. We have the regions. I'm trying to follow the pattern that they are using GradWorks. So if you are a new engineer and you want to onboard, from this image, you can understand that we are using the US1, US1, the name of the cluster that we have, management, non-prod, prod. And probably you have a question what is _global. We have some resources that are globally, like in Route 53, you don't have specific region. The ACMs, they have specific region in the specific region. So this is the reason that we are storing there all the resources that we have in Terraform to make our life easier. And in the next image, you will see that we have some empty variables, because Terraform or a Doppler will propagate all of these changes based on the cluster configuration that we have. As you can see, we have all the applications like Argo rollouts, workflows, limit updated in pulse mode, because when we are creating a new cluster, we want, let's say, to test, and I want to enable only these 5 add-ons. This helps us to make our testing to ensure that we don't have break changes. Security and compliance, we are storing data, so we have Vanta, we are getting a tons of alerts that when we don't do something, if we don't add them tags, so we are SOC 2 compliant, GDPR, CCPA compliant, we have SSO sound support, and we are multi-region and multi-cloud, but the multi-cloud doesn't have any production traffic yet because we are waiting for a customer and when we have the approval. The reason that we have a multi-cloud solution is not for disaster recovery reasons, but we have some specific customers that they don't want to share their data with AWS, so they are looking for different providers. Because if you want my opinion, if you are a small company and you are trying to do all this for disaster recovery, it doesn't make any sense. Scaling and optimization, we're using Carpenter. Probably a lot of people, you have the question why you don't use cluster autoscaler. Carpenter is quite a bit more sophisticated, and Carpenter can help you to use, you don't need to have over provisioning clusters, you don't need to have, let's say, only some specific nodes. So it helps you to make your life easier. It's quite a bit harder if you have only experience with cluster autoscaler to install it. But I believe in 1 week from now, it will be very easy to do it. Monitoring, observability, and incident management. As I mentioned before, we're using Grafana Cloud for all the dashboards that we have. We're using Prometheus Alert Manager because we have created specific alerts based on who wants to page this alert. Because in the previous month, when we had an incident, we dumped in all in one call and we tried to find what's the root cause and try to help. But right now we have some specific alerts. And from these specific alerts, we have a requirement that we need to have a specific runbook each time that we have this problem, a front-end engineer to be able to run this thing to fix the problem. Of course, if we have a problem that we cannot fix, they will page, let's say, the platform. We are using logging tempo for logging and tracing. We are not doing something really specific. And of course, every time that we have an incident, we have postmortems because it's really good to have, let's say, all of this knowledge in one stage to understand what is going wrong. And this is something that we did in the last incident. We shared these things with our customers, and we got very good feedback that they are really happy with all of this information. And also, I believe that we are creating a better communication because, you know, it's really hard to have 100% uptime. So it's really good to share with your customers what is going wrong. And last but not least, we created some SLA, SLO, and SLI metrics. I'm not really proud. It's, let's say, really stupid in code. But this was a start, and I believe in the next month I will be able to improve it a lot. But for now, we are just taking the latency and stuff like that. I'm saying that because we had a specific team that developed all of these things, so it was really, really different. Some future plans that I mentioned before, we have the multi-cloud support that we need to do. Right now, we are multi-region in US East 1 and the US 1. We are trying to have environment consistency between staging, production, and environments. And also, we are trying to treat our staging environment as a kernel because we have engineers that they want to develop, let's say, different branches in the same time. So right now, this is, let's say, the next epic that I will have to provide in our engineers this feature, because right now we have all of these things inside in 182 instance, so you can understand that the parity is not really, really well. And of course, we need to enhance the deployment strategy. to connect Argo rollouts with the error rate from Prometheus, and when we have a problem, to have an automatically rollback to avoid to have downtime. Thank you for your attention. Of course, if you have any questions, I will try to do my best to answer all the questions that you have. I don't know how I can find the questions. So if you can.
Question, you mean Menti?
Yes, I can go to Menti.
I think there's no thing.
In white lab and not Golang, it's not for mine.
Yeah.
I think we have one question about, can you describe how do you do end-to-end testing from its operator? Okay.
Those are all for
Those
those are all for the previous presentation.
Okay. Do you have any questions regarding the presentation that you want to ask?
I don't have one.
Okay. Let's start.
In the migration of from lambda expressions to micromonolith, because it's 5. Is there something that you missed? Is there something that was better before than a little bit? I don't know.
Yes, great question. I missed something that I have mentioned more than 20 times when we started. We didn't have liveness and readiness probes, so this created problems during the deployments because we ran really quickly to do it because it was really hard to maintain 2 different branches. I forgot to add readiness and liveness probes. So every time that we had the development, we had a lot of problems because,
Yeah. But in general, the engineers in the team are happy with the migration because they have more control over whole.
Yes, if we compare the metrics-oriented mindset, with Lambdas, we had, let's say, 2 or 3 releases per week. Now we have, let's say, 3-4 releases per day. It's automated, and we don't have something that we need to avoid. So we can proceed with a lot of deployment. If I remember correctly, because this is automated, we are running in 1.15.30. So we have a lot of versions that last for months.
Okay. Thank you.
Sorry. Go.
Is any part of the infrastructure running on-premise or everything is on cloud provider?
Everything on AWS and some of them in Google Cloud. But it's not production traffic yet because we're waiting for a customer, and after that we will proceed. We don't want to add more complexity without any reason. We don't want to have multi-cloud solution for disaster recovery. We are doing that only for some customers that they don't want to have the data in AWS.
Okay, but in any way, since everything is in Terraform, it would be easy to move to another provider.
Yes and no, because you need to use all the different modules. Also, I need some time because I'm using AWS and I didn't have time. I have some experience with Sotiriou. I'm a huge fan of Sotiriou. But in Google Cloud, let's say I cannot use AWS and I need to use something different. So if you have any problems, I don't know.
Nestoras, nice to see you again. One question regarding Kubernetes.
Yes.
It supports only AWS, right? In Google Cloud?
No, I think when I read that you can deploy it also in Google Cloud and in Azure, it's not a strict constraint.
Nice.
If you have different opinions, just let me know because I read it. Okay.
Again, on the same topic about multi-vendor support. So how do you figure out that you have, you're as close as possible to your production, which is AWS or TCP. So how do you compare? Or what were your challenges replicating everything?
We are not replicating data, so this is the good part, because we have their own database.
Replicating your architecture.
Yes, it's really easy because just we need to implement the Terraform modules that we have, and after that, we have end-to-end tests to check that everything works properly. So we can proceed. If we had, let's say, to replicate the data, it was really tricky and probably I'm not able to do it alone. Go on.
What's the monolith about, and how does it affect your performance and downtime?
Okay. For the problems, I mean, for the incident that we had with a lot of microservices, I think we are in a very better way. And also, it's a feedback that we have with the customers. Also, we are using code zero for authentication. So because we are using more than 50 microservices, you can understand that every time that we communicate with other microservices, we need to re-authenticate the request. So this helped us a lot to reduce the time. So we are getting a lot of feedback that our performance is really, really well, but also our backend engineers restructure, refactor a lot of things. So I cannot say that this is only for because we don't have the authentication that we had in the previous month, but also they did a lot of changes with workers and stuff like that.
If you measure it out.
We are measuring right now with CloudWatch. It was really hard, so this is the reason that I cannot compare these two numbers. So it's like the feedback that we have. But with CloudWatch, unfortunately, it was really hard to have this number. If you ask me for the ALD latency, okay, it's better, but I don't have the numbers right now to provide them.
There are some questions coming into. Okay, yeah. Do you want me to read them to you?
Yes.
So the first one is, how many non-prod clusters do you have? Do you have staging, testing, stress clusters in every region you operate?
No, we don't have in every region that we operate, but we can do it because if I want to test something in EU West 1, I will run the test to do it in EU West 1. If we are doing radical changes, we will provisionally take these changes in US 1 and also in EU West 1. But we don't have staging clusters that running every day. We have staging clusters based on the requests that we have, because we can destroy and we can create them. So during the weekend, we don't have any clusters because we are trying also to reduce the AWS cost.
Do you use Grafana Cloud for logging too, or do you have logkey inside your management cluster?
No, inside Grafana Cloud. We are sending there all the logs.
How does ArgoCD image updater work together with ECR? Is it seamless?
Very good question, because when I implemented that, I spent more than 3 weeks and I didn't understand why it didn't work. ArgoCD image updater has a bug. I don't know if they fix it, but if you are not deploying things in ArgoCD namespace, ArgoCD image updater will not trigger to propagate all the changes in the Kubernetes cluster. So I spent more than 2 weeks to understand what is going wrong. So if you're using ArgoCD image updater, I don't know if you have a hack, but the solution that I did, I turned everything in ArgoCD and I used different names.
What CNI you use for your cluster?
I think I have already mentioned AWS CNI, but we have in our backlog to use Cilium when we have the multi-cloud solution.
Are you affected by the acquisition?
No.
Okay.
Yes.
That's if it was how you mentioned how many people propagate versions.
Versions, you mean in the application or in the application? In the application, we have some GitHub action runners that each time that we